Now, in this we are discussing ePWM, right? What is the purpose of PWM? Why we have to do this experiment? Like why we have to? What is the importance of PWM module in power electronics?
To create the gating pulse for the MOSFET.
Yes, for either MOSFET, any switch, it works based on gating pulses. So we have to. Basic thing is that ePWM module will generate gating pulses. Okay, so what will be the value of output of ePWM pulse? It will be between 0 to 3.3. Okay, either I means 3.3 volt, 0 is low. Okay. So how you will generate this pulse? Generally, we can generate by comparing with ramp signal or triangle signal, right? Okay. Generally, PWM is generated with modulating waveform, modulating wave and carrier wave. Right. Here triangle is the carrier wave. Sawtooth or triangle is the carrier wave. And here modulating waveform can be constant or sine, or it can be any other waveform. Okay. So triangle in this sawtooth waveforms, we have two types of sawtooth waveform. Okay, we have up. This is called as up counter. Okay, this is called as up counter. Why it is up counter? Since it is going up, means it is increasing. Okay, so this is called as down counter. Okay, so and how triangle is created? Up and down. See here, once it is going up and once it is going down. So this is called as up down. Okay, it is having both up and down. So it is called, triangle is called as up down counter. Whereas these sawtooth waveforms are called as up counter and down counter. Okay. Generally we use triangle waveform. I mostly use triangle waveform. I will explain with triangle waveform. Okay. So when you are configuring in ePWM module, you can configure these three triangles. And in this, here you can see ePWM module. Here we have 8 ePWM modules. Okay, so here which ePWM module you want to select. Okay, here I am showing for ePWM 1. Okay, and this is next we have to check time period units. It is in clock cycles. Okay, and where you want to specify the timer period. Okay, because timer period is nothing but how you want to here timer period is nothing but see, this is there, right? This is nothing but counter. So how it will increase? It will go up to certain value. Okay, this is called as TBPRD. Okay, so this will decide the frequency. This will decide the frequency of your PWM. Okay, if you enter different values of TBPRD, it will change your frequency, PWM frequency. Okay, so what is the relation for PWM frequency and TBPRD? It is PWM clock by 2 into FPWM. Here FPWM is nothing but frequency of the PWM. What frequency you want to operate it? Either 10 kHz, 20 kHz, 30 kHz, whatever you want to operate it, that is the PWM frequency. And PWM clock, the input clock frequency for PWM module is 100 MHz. Okay, PWM clock input frequency is 100 MHz. So you have to substitute here 100 MHz and 2 into 100 MHz by 2 into PWM frequency. So this will give the time base period. Okay, so based on this, the frequency of your PWM is decided. Okay, next. Okay, as I told you here, at what point we have to load that PWM or TBPRD value. Okay, it is decided. It is equal to at 0, it will be loading the value. Okay, and here this counting mode I have discussed previously, right? Up count, down count and up down count. Okay, whether you want to synchronize or not. Okay, for now I am disabling the synchronization. If in case of three phase, if you want to synchronize, like in 3 phase, you will be using only one triangle. In case of 3 phase, you will be using the same triangle for all the 3 phase waveform, right? Same triangle will be compared with all the 3 phase waveforms. In that case, you have to synchronize all the ePWMs. So then you will be using synchronization action. Okay, and in this, when synchronization is enabled, then you will be seeing to which PWM you want to synchronize it. Either ePWM1 or ePWM2, ePWM3, or which module you want to synchronize this, you can synchronize it. Okay, and this time-based clock period, generally we will keep it 1. Prescalers, these are called as prescalers, so it will be 1. Okay, if you adjust these values, then your PWM frequency will be reduced, your PWM clock frequency will be reduced. As I told you previously, PWM clock, right? PWM clock is the, if this is the PWM module, whatever system, from system clock, it will be deriving the PWM clock. Okay, there will be a prescaler. Prescaler is nothing but it will be dividing the frequency by multiple of 2. Okay, it will be reducing the frequency of the clock by multiple of 2, and it will be giving here what is the frequency of launch XL 28379D. It is 200 MHz. Okay, so it will be divided by 2 and it will go to the PWM module. So PWM clock frequency will be 100 MHz. Okay, again, in order to divide further this PWM clock, they gave these prescalers. Okay, So they gave TBCLK and HSPCLK. Okay, they gave, in order to further divide this 100 megahertz into 25 megahertz or 50 megahertz, if you want to divide it, then you can use this, or else you can keep this 1 Okay, generally you don't need to touch this one. I am saying if you want to explore more, you can use this. Okay. Till now you understood, right? Okay. So how you will be generating the pulse? Next. Why it is not?
बोर्ड के अंदर ना
See here.
In bottom pen.
पेन सर यस
See here how you will be updating the pulse. For example, I have taken up down. Okay. So if there is a constant modulating waveform, so I want to generate a pulse. Okay. So since it is rising of the triangle, it is called as up, and what like falling is called as down. Okay. So when it is rising, it is called as CAU. It is compare A up. If you are using compare A module, in this you will be having, I forgot to say, in this you will be having two compare modules. Okay, compare A and compare B modules. Okay, which are generating the triangle. Which will be used for comparison of modulation waveform with triangle. Okay, so in this, when it is rising, it is called as compare A, and when it is falling, it is called as compare down. Compare A down. Okay. When what action I am taking here, when it is rising, it is clearing. Means the pulse will fall at this point. Okay. Previously it was high. Now the pulse will fall. And what action we are taking? Compare A down. It will set. Set means it will go high. Set means it will go high, and clear means it will go down. Okay. So at this point, compare A up, it will be going up, means it will be clearing, it will be clearing, and at this point it will be making high. Okay. So here this is 0 point. Okay. These are 0 points, and this is PRD. This is time based period, as I told previously. So here they wrote, here it is cleared, here it is cleared, here it is set. Okay, so here it is set. Previously it was clear, it is set here, and at this point it is clear. Okay. I am saying based on this one, if this is the 0 point, okay, at this 0 point it is set, and at PRD it is clear. So your pulse will be like this, or your output pulse will be like this. Okay. If you have any doubt, you can ask me now itself, because when you are generating pulses, you can feel easy. This is for ePWM here. Okay, since I enabled like ePWM in this launchpad, you will be having PWM 1A, 1B, 2A and 2B. Why they have given A and B? In ePWM 1 itself they have given A and B. Why? Because it can be useful for triggering one complete leg. Okay, so A will trigger the top leg, top switch, and B will be triggering the bottom of the switch. Okay. So now we will discuss about B. In B we can see it can be enabled. If you want to use for bottom leg, you can enable it. Okay. After that, here I don't want to take any action. Do nothing and do nothing. Here see, now what I wrote is that here at compare A up, in the same way in compare ePWM B also I am doing the same. When it is rising and clearing, previously I explained, right? So when it is rising and clearing the pulse, means I am making the pulse low. When it is when it is going down, I am making the pulse high. Okay. Or else if you want to create inversion of the pulse of ePWM A, you can click this option. You will get the inverted pulse for ePWM A. Okay. So here how you will give the modulating waveform. Okay, either you can give the modulating waveform through dialog box. Dialog box means here in this box, or you can give it through external. External means if you give it through input port, you can see the difference, right? Previously we don't have this input, now it got enabled. So now you can connect constant or sine or whatever waveform you want to compare with triangle, you can compare with this waveform with triangle. Okay, so it will be compared with triangle and it will generate the pulses. Deadband module. Okay, what is the use of deadband module? Why we have to use deadband module? You studied inverters, right? What is the use of deadband module? I have one leg. Okay, if both the pulses are overlapping, okay, they are overlapping, what will happen? It will get shorted. So if it gets shorted, it will damage the source. So in order to avoid that, what we are doing, we should avoid this common portion, right? So that is why deadband module is there. Okay, when top pulse is falling and bottom pulse is rising, this is the top pulse. Okay, I am writing as 1A and bottom pulse as 1B. At exact instant it is rising. So here at this point there is a chance for shorting the leg. Okay, if you want to avoid this, you have to give you have to raise it after some time, after some microseconds. It is decided based on the turn off time of the switch. Okay, generally we keep 3 microseconds, or you can decide it based on the turn off time of the switch. Okay, so you can I am saying randomly, like it can be 3 microseconds. Generally what we can keep is 3 microseconds. Okay, I think you can make this ePWM module. Okay.
So why we are using dash A and B both?
A and B is for top pulse and top switch and bottom switch.
But sir, here deadband is for A, means it is taking care of the both top and bottom.
It will, see here they have given for both, no?
Means if we select A, then it will take care of both the switches, top and bottom switch,
Here the options are there.
to protect them short circuiting.
See, here deadband polarity is given, right? You want us to?
I'm saying that PWM A is for the top switches,
Yes.
B is for the bottom one.
Yes.
Here we have used the deadband ePWM A. Means it will take care whether the top switch and bottom switch should not get on simultaneously.
Yes, it will take care of only top switch.
Deadband.
Means 1A is taking, if you are using for 1A, it will take care of only 1A. If you are enabling it for B, then it will take care of B, or else it won't take care of B.
But sir, if you are not switching on both A and B, then how it will know that both are getting on at the same time? So जैसे हमने A यूज़ किया है ऊपर वाली स्विच के लिए, B यूज़ किया है बॉटम स्विच के लिए. ये डेडबैंड A का काम ये है कि मतलब ये टॉप और बॉटम स्विचेस एक साथ साइमल्टेनियसली ऑन नहीं होना चाहिए. तो अगर हमने A वाला ऑन किया है और B वाला ऑन नहीं किया है, तो B वाले को मतलब बॉटम स्विच को कैसे पता चलेगा, क्योंकि उसको तो हमने डेडबैंड उसका एक्टिवेट नहीं किया, तो कैसे पता चलेगा कि ऊपर टॉप वाली और बॉटम वाली एक साथ शॉर्ट हो रही है? तो या तो इसको दोनों एक साथ यूज़ करना होगा या तो दोनों.
We use, actually this will be linked. 1A will be linking to 1B also.
Yes.
You will be giving complementary action. Actually here complementary high pulse will, complementary high action will be there, one option. So that option will be taking care of that whatever inversion, whatever I told you previously, it won't allow you to raise the pulse at the same time.
Yes.
That complementary high, it is generated from 1A. Okay. For 1A pulses, whatever you are generating, it will go the same. But for 1B, it will delay the pulse with the deadband module. It will go through deadband module, it will delay the pulse, and then it will go to 1B, so that it won't short that completely. Okay. You can make one ePWM. I think you can make this ePWM, right? You take one constant waveform. What you will do is that this is my modulating waveform and this is my carrier waveform. Okay. You generate pulse. Okay. You generate pulse at this point, like this. This is your first experiment, 1A. Okay. In 1B, what you will have, you have to take sine PW sine, and you have to compare with this triangle, and you have to generate the pulses. This is your 1B. You have to do these two, and you have to show. No. Like what will happen is that 1A is there, 1A pulses will go straight, but when it is going to 1B, before going to 1B, it will go through deadband module and it will go to the 1B, so that it won't make that short, and it will delay the pulse, it will shift the pulse. Okay. If both are going, this deadband module will take care such that these two won't get rising at high, like it won't be, both of them won't be high at one place. This module will be taking care of that one. Okay, there are some options, like if you go through, there are complementary high, complementary low, high, low, there are many options in that. Okay, in that generally we choose complementary high. When we are using inverters, we use complementary high. You will, if you want to create a module, if you want to create a separate Simulink file for this, you have to go into modeling. Okay, when you are creating a file, you have to go into modeling, click on model setting. Okay, and here in hardware implementation, if you see, it is showing that determine code generation by system target file. Okay, here you have to change it to F28379D, launch Excel F28379D. Okay, so it will adjust all the things. See, now it is showing all these options, right? So in this, if you go to target hardware, okay, in target hardware external mode, if you see to which serial port it is connected, it will show here. Okay, whatever basic thing, first when you are connecting your USB launchpad USB to your MATLAB, first you have to verify this portion. Okay, whatever serial port it is showing in device manager, it has to match with this serial port. Okay, once these two are matching, then next step you have to take care of this is that here in device manager, can you give me one launchpad? One launchpad. See, here it is showing COM13, right? So what I have to check here is I will go to device manager. This is very important thing, you have to pay attention. Here in device manager you have to go to ports, COM ports. Okay, here XDS100 class USB serial port is COM13, right? Here this COM13 and that COM13 is matching. And next important thing is that you have to see in properties, when you right click, here you will get properties. In properties you have to see port setting. Okay, in port setting here it is 9600. If it is 9600 it won't work. So you have to increase it to 1,15,200. Okay, your baud rate you have to increase it to this value, then it will work. Okay, you have to make this setting and then you can dump the code. Okay, these are basic things which you have to pay attention. That's all.